Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Advanced Honors Algebra 1 and 2 class. Today we're going to be talking about modeling and solving problems with quadratic equations. It's actually very cool stuff, very fun stuff, and I hope we're going to learn a lot here. All right? All right, let's just start by just getting to it and solving some problems, because all of the skills that we need, we've already learned. We know how to factor, we know how to solve quadratic equations by factoring, so now let's see how they apply to word problems. Hopefully you see, I'm going to put this in black, but it should be blue. This is an 11 here, that makes it even worse. Hold on, let's see if, this is 11, okay. I didn't put it in red originally because this 11 I wanted to be associated with the width, but okay. You're constructing a frame for a rectangular photo shown. This happens all the time, guys. Happens at all sorts of arts and crafts stores. Some people make a living, a very good living actually, from making frames and different kinds of furniture and cabinetry and stuff like that, called carpenters. Anyways, you want the frame to be the same width all the way around the total area of the frame and photo, okay? To be 315 inches squared. What should the outer dimensions of the frame be? So again, you are constructing a frame for a rectangular photo shown. You want the frame to be the same width all the way around the total area of the frame and photo to be 315 square inches. What should the dimensions of the frame be? Well, okay. First of all, when we're talking about area of a rectangle, please remember the formula for the area of a rectangle. And area of a rectangle equals length times width or base times height. Same thing, same difference there. Okay? All right. So when we're looking at this, we can see clearly that the width, which is in blue here, okay, this is the width. The width is 11 inches of the actual painting itself. Okay, the width is of the actual painting itself is 11. And the length, which is in red here, the length is 17 inches. That's the length of the actual painting itself. But if you've noticed, I want the frame to be the same width all the way around this painting. And I want the total area of both the frame and the photo to be 315 square inches. So, since I need a width of X on both sides of this painting, the true width of the frame and painting is going to be 2x plus 11. Why 2x? Because you have x width of this frame on the left side, the 11 inches of the actual painting, plus another x inches on the right side of the painting to complete the frame. So x plus x is 2x. Plus 11 inches of the actual width of the painting, you have 2x plus 11. The length or the height works a similar way. You have the bottom part of the frame, which is x, plus the actual height of the painting, which is 17 inches, plus the actual width on the top of the painting, which is another x. So x plus 17, that is my length or height. And I just noticed here I spelled length incorrectly. Should be like that. Okay, so now this area should have a total area of 315 square inches. That's what I want the total area of both the frame and photo to be. So now it's just using the skills that we've learned. Okay? using the skills that we've learned for a long time. So let's go ahead and solve this. First of all, we're going to FOIL out these two binomials. So when we FOIL this out, we're going to be left with 4x squared. Okay, sorry about that. So we've got 2x times 2x, which is 4x squared. 2x plus 17 is 34x. 11 times 2x is 22x. And 11 times 17 is plus 187 equals 315. Combine like terms. So I've got 4x squared plus 56x plus 187 equals 315. Let's go ahead and solve this quadratic function or equation, however you want to look at it. Subtract 315 to both sides. And I've got 4x squared plus 56x minus 128. Before you freak out on me, remember what we've learned. Always factor out a GCF if possible. And in this case, factoring out a GCF is possible. So I'm going to be left with x squared plus 14x minus 32 after I factor out my GCF of 4. Now let's factor and solve. So I've got my setup, x times x. What times what is negative 32, but when added together is positive 14. We're looking at positive 16 and negative 2. My zero product property. 4 cannot be set equal to 0. There's no variable. 4 cannot equal 0, so we don't have to worry about that. But we do have to set x plus 16 equal to 0 and x minus 2 equal to 0 using the zero product property. So x can equal negative 16 or positive 2. Now, since we're dealing with word problems, real life situations, we have to make sure that the answers are viable, that they work. Let's look at negative 16 here, guys. Okay? If I plug negative 16 into here, negative 16 times 2 is negative 32. Negative 32 plus 11 is a negative 21. I cannot multiply a positive times a negative to get me a negative. Okay, that's just not going to work out. All right? But if you don't believe me, let's just go ahead and go all the way. Let's try this negative 16 all the way. If I plug in this negative 16, like I said, I'm going to have negative 32 plus 11 times negative 32 plus 17. I want to see if that equals 315. Okay, let's see. I've got negative 32 plus 11, which is a negative 21, times negative 32 plus 17, which equals a negative 15. And actually, you know what, boys? This will work because negative 21 times negative 15 equals 315. However, here's the situation. I did this because I know a lot of you were going to plug it in and you were going to go and say, oh, but it's 315. Yes, it does work. However, can I have an x that is negative 16 inches? No, I cannot. So negative 16 cannot work. Even though if I plug it back in, if this was a theoretical problem, it would work. But since it's not theoretical, I'm working with real wood, I cannot have negative 16-inch frame. Now, x can equal 2. And if we plug it in, it will work. 2 times 2 is 4. 4 plus 11 is 15. 2 times 2 is 4. 4 plus 17 is 21. And 15 times 21 is 315 squared inches. And bingo. So x, which is my frame, has to have a 2-inch thickness. And that's the beauty of quadratic equations applied to word problems. Let's move on. A child throws a ball, sorry about that. A child throws a ball upward off a cliff, a height of 240 feet above the sea level. Okay? The height h of the ball above the water in feet at any time, t in seconds, can be modeled by, not bt, sorry about that, but by the equation h equals negative 16t squared plus 32t plus 240. A, when will the height of the ball be 240 feet above sea level? B, when will the ball strike the water? Let's go ahead and take a look at what we're dealing with here. Okay? We have this cliff, all right? And the height of this cliff is 240 feet. And you have this kid, all right? Horrible stick figure. That's all right. Not good either, but whatever. It is what it is. Okay. He throws the ball, and the ball is going to go up, and then it's going to splash into the water. Okay. Remember what we were talking about when I taught you guys how to solve quadratic equations. We're really solving for a quadratic function, which is a parabola, this U-shaped graph that I kind of sketched out here. Okay? So to determine when the height of the ball will be 240 feet above the sea level, we have to let h, which is the height, be 240. Because I threw it up. When it's up here, it's higher than 240. So I basically want to know, when is the ball here? Okay? And also, when will the ball strike the water, which this height would equal 0. So I first want to find when, after how many seconds, will the height be 240, and when will the height be 0. Okay? So, A, I want to find when the height will be 240, how long will it take? Well, if my height is 240, got 240 equals negative 16t squared plus 32t plus 240. Solve like you know how to do. Subtract 240 to both sides. I've got 0. That equals negative 16t squared plus 32t. Factor out the GCF of negative 16. When I factor that out, I get 2 squared. 2 squared. I'm sorry. Yeah, t squared. No. Pay attention, Mr. Morrow. Factor out a negative 16t. Sorry. And that's going to leave me with t minus 2. Now I set both of these equal to 0 because of the zero product property. So t can equal 0 and t minus 2 can equal 0. So t, the time will be 0 seconds and 2 seconds. That's when the rock that this person is throwing will be at 240 feet. Let me explain why. Right here when he first throws it, okay, it's at 240 feet. That's at 0 seconds. Okay? Then it goes up for a little bit, and then boom, it comes back down right at the same spot where it began, at 240 feet. So before he throws it up, it's going to be 240 feet, and then it goes up, and then it comes down, and it hits 240 again as well. And this drawing is a little bit elusive, okay? Let's say that the actual height, 240, includes the height of his hand, because the ball is really technically here when he's about to throw it, okay? So this is the height that we're looking for at 240. All right. B. When will the ball strike the water? Okay. Now, let's solve for that one. B. When will the ball strike the water? The height of the ball will be 0 feet when it strikes the water. So, we set the height equal to 0. 0 equals negative 16t squared plus 32t plus 240. Let's go ahead and factor out a negative 16, which leaves me with t squared minus 2t minus 15. Let's factor this out. I've got negative 16 times t minus 5 times t plus 3. Please remember, what times what is negative 15, but when added together is negative 2. And then negative 16 cannot be set equal to 0 because negative 16 does not equal 0. But using the zero product property, t minus 5 gets set equal to 0, and t plus 3 gets set equal to 0. So t can equal 5 seconds or negative 3 seconds. Now, sorry about that. Now, negative 3 seconds, okay, cannot exist. There cannot be negative 3 seconds. Time just doesn't work that way. You can't have negative time. So it's going to take 5 seconds for that ball to hit the surface of the water. Okay? Not too complicated, right? Isn't too bad. I hope. All right, so that means that from the time that he threw the ball up, it took 5 seconds to splash into the water. Easy peasy, lemon squeezy. All right, let's move on. A carpet installer finds that the length of the rectangular hallway is 3 more than twice the width. If the area of the hallway, sorry about that, there's a little typo there too. If the area of the hallway is 44 square feet, what are the dimensions of the hallway? Okay, well, let's talk about the length and the width. Set up a little table. What do we know nothing about? It says that a carpet installer finds that the length of the rectangular hallway is 3 feet more than twice the width. So we know nothing about the width, and the length is 3 feet more than twice the width, so 2x plus 3. The area is 44 square feet. What are the dimensions of the hallway? What are the length and the width of this hallway? It's very important because he's going to be installing the carpet. He needs to know how much carpet to lay down. So the length, which is 2x plus 3, times the width of x, that's area. Remember, area equals length times width, equals 44 square feet. So let's go ahead and distribute. So I have 2x squared plus 3x equals 44. And I have 2x squared plus 3x minus 44 equals 0. Now you can choose to use the box method or the Cuban method to solve this. I'm going to use the Cuban method, okay? I've got 2x, 2 times negative 88. Times negative 44 is negative 88. I'm sorry, give me 1 second, please. Okay, sorry about that, guys. Alrighty. So, like I was saying, A times C is negative 88. What times what is negative 8? But when added together is positive 3. We're talking about a positive 11 and a negative 8. Artificial factor of 2. So this leaves me with 2x plus 11 times x minus 4 equals 0. I use the zero product property. So I set 2x plus 11 equal to 0 and x minus 4 equal to 0. So x equals negative 11 halves, which again, we cannot have a width of negative 11 halves, so that goes bye-bye. Or x equals 4, which is exactly what we're looking for. So we plug it in. The width is 4 feet, and the length is 8 plus 3, 11 feet. And 11 times 4 is 44 square feet. Nice and easy. Okay, the height of a triangle is 5 inches less than the length of the base, and the area of the triangle is 42 inches. Find the height of the triangle. First of all, please remember that the area of a triangle's base times height divided by 2. So now let's set up a table. I have my base and I have my height. What do we know nothing about? The height of a triangle is 5 inches less than the length of the base. So we know nothing about the base. But we know that the height is 5 inches less than the length. So remember, less than, flip. So height is x minus 5. Okay? And we know that the area is 42. So my area, which is 42, equals my base, which is x, times my height, which is x minus 5, divided by 2. Let's solve it. All right. First of all, let's get rid of this fraction. So we multiply 2 to both sides, giving me 84 equals x times x minus 5. Distribute. 84 equals x squared minus 5x. Subtract 84 to both sides. So 0 equals x squared minus 5x minus 84. So what times what equals negative 84, but when added together is negative 5? Hopefully you've figured out it's negative 12 and positive 7. So using the zero product property, x minus 12 equals 0, x plus 7 equals 0. So x equals 12 or negative 7. And again, I can't have a base that is negative 7. Okay, just can't happen. We can't have negative inches. So go ahead and get rid of that bad boy. And x equals 12. And 12 minus 5 is 7. So I have now a base of 12 inches and a height of 7 inches. And 12 times 7 is 84, divided by 2 is 42, and bingo, that works. All right, let's move on. Let's talk about the Pythagorean Theorem for a second. The Pythagorean Theorem works with right triangles and right triangles only. You know that a triangle is a right triangle if it has this little symbol. That symbol means that it is 90 degrees. That's what that symbol means. It's 90 degrees. That is a right triangle. And a right triangle, like all triangles, has 3 sides. But the side opposite the 90 is always called the hypotenuse. And then either of the other 2 sides are called legs. They're interchangeable. I labeled this one A and this one B, but you could have labeled it the other way. What you cannot change is the hypotenuse. That is always C. And the formula for the Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. Okay? So in other words, A squared, one of the legs, plus B squared, the other leg, equals C squared, the hypotenuse, squared. How can we use this? Very easily. Let's say I want to find the length of each side here. Well, I know the hypotenuse is 15, but I don't know the height or the base. I don't know the other legs. So let's use the Pythagorean theorem. A squared plus B squared, B is x minus 3, B squared equals C squared, which is the hypotenuse squared. So I have x squared plus x squared minus 6x plus 9. Please remember this is a perfect square, guys. There's a formula here. It's the first term squared minus 2 times the first times the second term plus the second term squared. If you need a review on that, that's in chapter 5. And that equals 225. 15 times 15 is 225. So now, let's see what we got. I've got 2x squared minus 6x, and 9 minus 225 is, I believe, negative 216, which equals 0. I can factor out a 2 from here, so let's do it. Let's factor out a GCF of 2, leaving me with x squared minus 3x, and 216 divided by 2 gives me negative 108. Okay, and that equals 0. So now I have to solve this function by factoring. So let's go ahead and split it up. I've got x times x. Sorry about that. Okay, guys, so what times what is negative 108, but when added together is negative 3? We're looking at negative 12 and positive 9. Negative 12 times 9 is 108. Negative 12 plus 9 is negative 3. And this is set equal to 0. So I've got, now 2 cannot be equal to 0, so we don't have to use that in the zero product property. However, we do have to set up x minus 12 equals 0, and x plus 9 is equal to 0. So x can equal 12 or negative 9. But if we go back to our original triangle, I cannot have a side that is negative. So this negative 9 goes bye-bye, and x has to equal 12. So leg A, or this side, however you want to see it, is 12. And 12 minus 3, this is 9. And if I do the math, 9 squared plus 12 squared, it will equal 15 squared, which is 225. All right, how about this guy? I've got my hypotenuse is 13, and I've got one side that is x, the other side that is x plus 7. So a squared plus b squared equals c squared. So I've got x squared plus x squared plus 14x plus 49 equals 169. When I go ahead and do the math here, I've got 2x squared plus 14x, and 49 minus 169 equals negative 120. That equals 0. So now let's factor out a GCF of 2, leaving me with x squared plus 7x minus 60 equals 0. So I've got 2 now. Set up my x and x. What times what is negative 60, but when added together is 7. That's going to be positive 12 and negative 5 set equal to 0. So x plus 12 gets set equal to 0. X minus 5 gets set equal to 0. X can equal negative 12, which cannot be, or 5, which can be because it's positive. So this side is 5. 5 plus 7 is 12. And 5 squared plus 12 squared, I promise you, equals 13 squared. All right. Last but not least, how does this work in the real world? Okay. A rectangular 20-inch television screen measured diagonally. So what that means is this, guys. When they measure TV lengths, okay, sizes rather, it's a diagonal length. So this here is 20 inches. So a rectangular 20-inch television screen is 4 inches wider than it is tall. Okay? So I basically have a length and a width here. So basically what I have here, it's rectangular. Remember that rectangles have a 90-degree angle at each corner. So this guy here, this is my hypotenuse. That's my C. Okay? Try to remember that. So what do we know nothing about? It is 4 inches wider than it is tall. So we know nothing about the length, and the width is x plus 4. So the width is x plus 4, and my length or height in this case is x. I want to find out if this TV will fit in our new media cabinet that is 20 inches wide. So that's what I want to find out. Will this fit in my media cabinet that is 20 inches wide? Well, let's find out. I got to find the actual width, so I got to find this guy. So I got a squared plus b squared equals c squared. Let's do the math. X squared plus 8x plus 16 equals 400. Okay, let's do the math. We've got 2x squared plus 8x and 16, and this looks like a 9, I'm sorry. It is a 4. 16 minus 400 is negative 384. Let's go ahead and factor out a GCF of 2, giving me x squared plus 4x and 384 divided by 2 equals 192. Okay, that's equal to 0. So let's factor this bad boy. We've got 2 times my setup of x and x. And let's see. What times what is 192? But when added together is 4. Figure it out. Okay, guys, hopefully, I know this isn't an easy one. This one takes a little thought. But hopefully you figured out that it was x plus 16 times x minus 12. Because 16 times 12 is 192. And I'm sorry, this should be a negative 192. That may have messed you up, so I apologize about that. 16 times negative 12 is negative 192, and 16 minus 12 is 4. Zero product property, x plus 16 gets set equal to 0, and x minus 12 gets set equal to 0. So x can be negative 16 or 12. Well, it cannot be negative 16 because you can't have a height of negative 16, right? So x can be 12, though. So that means that it is 12 inches high or tall, and 12 plus 4 is 16 inches wide, and yes, it will fit in our new media cabinet. And that is the power of word problems and quadratic equations. Thank you so very much. I hope you learned a lot. Have a great day and enjoy. Bye-bye.